We are finally seeing some all-in-one power stations entering the market with split phase 120, 240 in a single unit. I've been moving away from testing these systems because there hasn't been anything truly revolutionary coming out, and frankly it costs me more to make these videos than I get out of them. But in this case, a reputable brand, Anker, delivered a truly unique product, and they offered to send me the unit and a small fee to cover the installation and testing of the product. So thanks to Anker for sponsoring this video to satisfy my curiosity and yours. Is this new system everything it claims to be, the holy grail of portable backup systems? Well, let's find out together. Welcome back to Projects with Everyday Dave. Let's do some real-world testing. I didn't want this to be a huge project, so I was originally only going to test a single F3800. But the first unit Anker sent me had some very slight shipping damage, so they sent me a replacement. Then it seemed like a wasted opportunity not to see what two units could do together. So I ended up doing way more than I originally planned, as usual, but it's been really fun because I've been able to do all kinds of really interesting testing. I've been able to run large induction power tools, my 4-ton heat pump, plasma cutter, welder, all kinds of things that I've never been able to run before. I even hooked up a 12 kilowatt on-demand hot water heater, and those results are also very interesting. But first, let's take a look at what just one power station can do, and then we'll bump it up to 2. Before we look at the typical hardware specs, let's try out the best feature of this unit, the plug-and-play, single unit 120/240 split phase whole home backup. You may be like me and already have a sub panel set up with emergency circuits and a generator plug. With this unit, I can use a standard generator extension cord, just like this one I purchased off of Amazon, and connect this directly to my generator plug on my house as a replacement for a gas-powered generator. I have a generator inlet already installed in my building, so I can simply plug one end of my cord into my generator plug and the other one straight into the unit. Conveniently, the split phase output has 2 plug options, and if you're using it, like I am in this case, as a replacement for a generator, you'll probably use the circular twist lock. So we can plug that in, turn on the AC. Heard the relay click, so now we're powered up, ready to go. The battery's at 38% right now. All right, let's flip the transfer switch, grid off, Anker on. And there we go. We are powering all of the emergency loads in the house. It's showing 200 watts right now. That's just a few lights. So let's see, right now on that circuit, I have a refrigerator, microwave, the well, emergency lights, TV, modem, security circuits, things like that. Let me throw on the well and a few other loads so we can see how it can support those things. All right, my emergency circuits aren't really pulling enough, so I've got a couple more electric heaters here so we can really push it a little bit. Okay, we've got over 1,000 watts there. All right, we're about 2,400 watts there. I mean, the fans aren't even coming on. It's not even breaking a sweat, so of course there's a lot of margin there. A 6,000 watt inverter basically means 3,000 watts per phase, so if I put both of these heaters on one phase, I mean, it's pushing that one phase pretty far, but there's a lot of headroom on this unit. We'll be able to run a lot of things. But for ease of use, 10 out of 10. Just plug in your generator cord and your whole house is ready to go, split phase. Man, that is so cool. Finally, somebody put it in one unit. No noise, no problems. I can even have some solar input. I don't have to go to the store to get fuel. With a few solar panels, I can run my systems for days with no problems. That is nice, and that is the key selling point of an all-in-one 120/240 system. It is just plug-and-play replacement for a generator. Let's run some tests to understand the practical, everyday usability of this unit. The max rated continuous output is 6,000 watts, which is very respectable. And I've connected it through the home power unit so that I can pull as much power from it as possible. I've turned on my water heater and we're pulling 5,563 watts right now, and that's very close to the limit. So I'm going to plug in this heat gun to one of the phases and we'll see if we can push it over the edge. Let's see what we can do here. Okay, we're up to 5,700 watts. $6,500 watts. Ooh, there it goes. About 6,600 watts. So it ran for a little bit over 6,000 watts, and it says its absolute max is 6,000. So it definitely achieves that and even a little bit more. And I was pulling that off of one phase. So that last 1,000 watts was offset. Probably if I had it balanced, we probably would have gotten pretty close to 7,000 watts total. You can also operate this unit as a standard UPS by plugging it into 120 with the provided AC cord, and it has a rapid 20 millisecond switchover. Or if you have connected through the home power unit like I do now, the switchover is automatically controlled through the home power unit. I tested the AC charging from the AC charging port, and it charges at 1800 watts, going from 0 to 100% in 2 hours and 46 minutes. And you can charge even faster than that if you have solar input at the same time. To get an understanding of the available AC delivered battery capacity, I charged the battery to 100% and connected it to my home water heater, which provides a nice mid-range constant 1437 watt load. It took 2 hours and 22 minutes to deplete the battery and consumed 3.56 kilowatt hours, which is 93% of the rated 3.84 kilowatt hour capacity. And that's really good, one of the better results for the usable capacity on these types of systems that I've tested. In a fantastic level of transparency, they actually published the part number for the battery cells that they use in the system. Based on that, I can see that they're letting the BMS use very close to 100% of the cell capacity, and the conversion losses to AC are really quite good. Knowing the available AC capacity, I charged the system back to 100% and connected my full-size refrigerator freezer, since that is something that most people will need to use in an emergency situation. My fridge ran for 23 hours and 18 minutes. It consumed 2.17 kilowatt hours during that period of time. The fridge is a good test since it's an intermittent load, and it highlights the inverter idle losses, because the inverter has some loss whether there's power being drawn from it or not. In this case, we were only able to use 2.17 kilowatt hours of the 3.56 kilowatt hour available capacity, or about 61% of the battery. And that's nothing to write home about. That seems like the inverter losses are pretty high. That would amount to 1.39 kilowatt hours of idle loss over the 23 hours and 18 minutes, or roughly a 60 watt idle consumption. Not terrible, but not great either. That's an important characteristic to understand when it comes to determining how much battery capacity you need for a power outage situation, especially if you don't have solar input to help keep the battery refreshed. For the DC battery capacity test, I pulled about 100 watts each from the 12-volt socket and the USB-C charging port at the same time. That drew about 218 watts according to the meter steadily, and it predicted it would last about 16.7 hours to go from 100% to 0% state of charge. The actual result was 16 hours and 51 minutes, so very close to the predicted time. I was pretty impressed with that calculation. The total consumption at the 2 meters combined was 3.4 kilowatt hours of the available 3.84 kilowatt hours, or a respectable 89% of the rated capacity. So you could run your CPAP and charge devices all at the same time overnight, no concern. The DC output performed very well. They all met or exceeded the spec. You have to push the button to turn on the 12-volt 10-amp port, but one nice feature is the USB-C and USB-A ports always have power available to them if you want to charge something, which is a really nice feature. You just walk up, plug it in, and it's running. The 12-volt 10-amp port held a respectable 12.3 volts at 10 amps and maxed out at 135 watts. The USB-A port voltage sagged a little bit, but that's likely just due to the line losses in the measuring device. I was able to pull 2.6 amps at 4.2 volts, and the unit showed 13 watts before cutting out. The USB-C port was quite good. I was able to pull 5.2 amps at 19.2 volts, which is 100 watts at the meter and 116 watts at the unit. That's quite a bit above what the unit is rated for. And in fact, I think that's the best result I've seen for a USB-C charging port on one of these devices. A nice feature that's available for charging is the ability to control the input current for the charge rate. The only negative is the software doesn't have a setting for controlling the total state of charge of the battery that it can fall to before recharging. That would be a nice feature because it would help increase the battery life. Also, it would be nice to have a PV priority mode. Right now I have some solar plugged in and we're bringing in 460 watts or so. And if I wanted to set it to PV priority so that it would just use the solar power and only charge the battery if it got below a certain point, that would be a really nice feature. But all of these things are software updates that could be added to later firmware updates. There's no hardware that would need to change to be able to do that. If you're using the home power unit to connect your power stations, a lot of those features are already available. They're just not available on the individual device. That brings us to my favorite part, solar charging. The unit has two MPPT inputs with XT60 connectors. The labeling is a little bit confusing. It's rated for 11 to 32 volts and 10 amps, or 32 volts to 60 volts at 25 amps, 1200 watts max for each port. Apparently, there's a different max current for lower voltage ranges. Of all of the specs on this system, this is the one that I would like most to improve. Because the max voltage is 60 volts, you're very limited on how many panels you can string together in series and are forced in most cases to put them together in parallel to keep the voltage that low. My biggest suggestion for a hardware improvement for Anker for this system is to bump the minimum voltage up to 150 volts. That would give us a lot more flexibility with solar panel connections. For example, Anker has these very nice 400 watt folding solar panels. They're 48 volts and 8.33 amps per panel. So you can't even put two panels in series because that would be almost 100 volts. In order to max out the 1200 watt input, you would need a 3-way branch connector with 3 400 watt panels in parallel, and that pushes around 25 amps through the connector. That's pretty high. It's likely to get fairly warm with that much current running through it. I'd rather see a much higher voltage and a lower current. Let's look at Anker's 400 watt folding solar panels for a minute. This is the most impressive folding solar panel I've seen. It's IP67 rated, and the panel itself has a nice, strong, flexible encapsulation. If the panel happened to get rained on, I wouldn't be worried about it at all. I'd have to say I don't think the panel could be any larger than this and still be considered portable. It's pretty heavy at over 25 pounds and a little bit unwieldy for one person to set up. But because of its robust construction, it's very doable. One thing you can't beat is 400 watts from a single panel. That is some serious input. The capability of these systems just gets better and better every year. I took some measurements with my solar irradiance meter and plotted it on a graph to show you the output that you can expect from one of these panels. On the graph, you can see at 1000 watts per meter squared, it'll put out a respectable 324 watts or 81% of its rated output. And that's pretty typical for a folding panel in weather conditions like this. One thing I did check, it is built with blocking diodes. So if you block out any one single panel, the rest of the panels will still produce their standard output. Now, if you block the bottom edge of every single panel, then you'll get no output because you've shaded the edge of every string. Now, when supplying power to the F3800, you will need the included branch connectors to put multiple panels in parallel. So let's run a few setups so you can see what to expect when you connect panels and how many you need to connect to get the output that you're trying to achieve. I've got 800 watts of folding solar panels attached over here, back to back, and they're going parallel. Got the two Anker flexible panels going parallel into port 1. Then I have 700 watts attached from this set of panels over here in parallel in port 2. And that is giving me 1130 watts. Ooh, so close to the max. We have to get there. Whoa, look at that. We're exceeding it. It says it's going to charge in 0.7 hours. 1340 watts. That is awesome. So I've got both ports. I have both Anker 400 watt panels, and in parallel with those, 700 watts of fixed panels. Then I have two 200 watt panels coming in parallel to port 2. And we are over 1300 watts. You can see it was doable. I was able to exceed the 1200 watt max for a single input, but you can see how challenging it is to max that out when your highest voltage you can bring in is only 60 volts. That being said, most people won't need more than a couple 400 watt panels to keep this battery charged enough to meet your typical emergency needs. And when you configure it that way in parallel instead of series, you're working with lower voltages, which is inherently safer. If you want to save some money, consider getting some fixed panels, and even fixed panels can be stored in a closet and pulled out later for an emergency. The only reason that you really need these more expensive, flexible, portable panels is if you're going to drive somewhere and go camping and things like that, and you really need to fold them up and put them in a trunk or something like that. Otherwise, there's no need to spend that kind of money. Now, this unit has plenty of power for pretty much any household appliance. Microwaves, dehumidifiers, window air conditioners, hot pots, coffee makers. You're not going to have a problem with any of those. The one thing these transformerless inverters tend to struggle with is induction loads, so big power tools. I have lots of large power tools we can try. And I don't expect it to be able to run any of them with just a single unit, but we'll give it a try so we can understand what the limits are. I'll start here with the drum sander. Woohoo! Hey, it actually works. Okay, that's pretty impressive. I've only had one other transformerless unit that was able to turn this on, and it only was able to do it every once in a while. This is a 1.5 horsepower motor, and it takes quite a bit to spin that roller up, so that's pretty impressive. Let's try the next one. All right, I have my full-size air compressor. Let's see if it'll work. Nice. I did not expect it to be able to run that either. That's impressive. So, I mean, it was started right up, 1400 watts or so there is bringing up the pressure. I'm impressed. All right, another big one. This one is a big load. Usually things just instantly shut off. Let's see. Oh! Man, that was close. It was almost there. So I think we found like the very edge limit for this thing. Every other power station I've ever tried just instantly shut off. That almost got there. That was so close. I'm sure when I connect 2 units, it'll fire right up, no problem. I want to give this dust collector one more shot. I have one of these soft starts from Active Start that's for power tools. I want to see if that's enough to put us over the edge. Meh, not quite. Bummer. All right, spinning up a table saw. Another big challenge. Nice. I have not had any other power stations that were able to do that either. So this has some really impressive startup power. I am really impressed with that. I mean, once you get these tools started up, there's plenty of power to run them. It's the startup current that causes all the problems with these transformerless units. So they've got some really good technology in there that's letting us power up some of these big tools. So the dust collector was the only thing that we couldn't start. All right, I've always wanted to get one of these units to power my budget Vevor plasma cutter. So let's give this one a shot. I have it connected to the 240 volt output, so that should give us our best chance of cutting something. What? That's interesting. The 250 volt one cut out. Let's try the 110. I can create a torch with 110. Let's see if we can cut something. Well, I guess not. Darn, it was doing so well. I thought it would be able to do this. All right, here we go. I'm going to try the cheapest little MIG welder you can get on Amazon. This is Simder. I'll leave a link in the description if you're interested. By the way, anything that I use in these videos, if there's any discount I can provide, I provide it in the description. So if you see something you like, be sure and check it out down there. And if you use those links, it does help out the channel a little bit. All right, here we go. Hey, it worked. It actually produces a nice little bead. I mean, I'm not the best welder in the world, but that produced a totally acceptable weld. And that is pretty impressive considering, I mean, this is just a tiny little 110 MIG welder. It worked pretty well. That's pretty impressive. And the unit ran, no problems. I love it. I'm impressed by both. I mean, this is just a tiny little cheap MIG welder. It made a really decent weld, and our power station powered it no problem. That's pretty cool that I can weld some things. I mean, you can take a battery to a remote location and a very portable little welder and do some repairs on things. That's pretty cool. Something that works. All right, now I think we understand the capability of a single unit. So I've hooked two up to the Anker Solex home power panel so that we can see how much power we can supply with two units combined. The installation for this unit is really pretty simple and nice and clean. We have two main connections. The first is the grid input. I just put a 50 amp breaker in my main panel and connected it with 6 gauge THHN through a flexible conduit. I put some eyelets crimped on the end of the wire, a little bit of heat shrink there just to keep things nice and neat, and then torque these down. I have line 1, line 2, neutral, and ground. I can use a 10 gauge ground here since it's a 50 amp breaker. Then for the output, I also use 6 gauge, and I ran that through a flexible conduit over to a sub panel, which you can get through Anker, or you can get your own. Just a simple sub panel with locations for all of your emergency circuits that you want to supply. In my case, I have a couple 30 amp breakers in there so we can run a 11 kilowatt on-demand hot water heater, but you would probably put in a breaker for your refrigerator, some emergency circuits, security, things like that. Really easy. Input from your main panel, output to your sub panel. Then there are a couple other connectors here. These are for sensors. They sense the amount of power that's coming in and out of your main panel. And if you have separate solar input, which in this case I do, so I'll show you that, I can put a CT sensor on that particular wire, and that allows me to understand how much solar is coming in and out of my main panel, independent of the solar that's coming in and out of these units directly. In my case, I already have sensors on my main panel. Those are for my Emporia View, so I can monitor everything with that system. Well, then I just clamped the sensors for the Anker Solex right above them, and that allows me to see if they match. I also have an Emporia sensor on my solar input, so I just added an additional sensor from the Anker system for that solar input. So it's that simple. It ends up with just 3 flexible conduits running out of the panel, which gives you a really nice clean look in the end. In your situation, these conduits may run right next to your sub panel, or like in mine, they may go through the wall to another location. And then you have the 2 main cables coming off for connection to the units. Then there's a breaker on each side that allows you to independently turn off each unit, as well as an emergency stop button and reset for configuration if there's any problems. Even though there's no display on the panel, there are some lights that allow you to know if everything is operating. There's a light for grid, one for each power station, and one that shows that the backup loads are being powered, as well as Wi-Fi and a power on and off button for the whole system. The home power panel adds significantly more capability to the overall system because it can monitor the loads in the main panel and the sub panel, as well as incoming solar from external sources. You can track all of that data, and you can set up time of use scenarios for managing your power consumption. That allows you to save money by using power from the battery during peak price times and then pushing power back to the battery when it's inexpensive. In fact, I set up a scenario and let it run for several days. It tracked the solar input from my main array. It also tracked the solar input coming into the individual units, although it lumps them together. You can't see them independently. It allowed the batteries to charge from solar and then push back out to the loads during peak charge times. It was really pretty impressive. It did it seamlessly, very smoothly, no large power spikes or anything. It apparently calculates the amount of time it has to push the power out and bring it back in, and does it in a very smooth way. That was really pretty impressive. All right, with both units connected through the home power panel, let's go back and check some of these bigger loads, the plasma cutter and the dust collector, and see if it'll run them. I ran an extension cord from the sub panel off the home power unit, so I basically have 2 units powering this thing, or at least that much capacity available. Let's see if it works. Nice. Well, that's all it took. Put two units together. I can plasma cut. I love it. All right, one more tool, dust collector. Man, that fired up no problem whatsoever. I mean, that felt like it was right on line power. So the extra unit makes a huge difference. And since the single unit by itself could almost start it and it could run most of the other tools, adding that second unit probably gives tremendous amount of margin. So it can probably run them with no problem. It's not like it's right on the edge of its capability. So that's pretty good. The final big run would be the heat pump. So I am using an active start on my heat pump, and without it, you're not going to be able to run it with most off-grid systems. So you're going to want to put one of those in anyway. I tried to start it with one unit off camera, and it did actually start, but it was making some weird noises, and I didn't feel good about it. So I don't want to repeat that. So I'm pretty sure it'll start with two. Let's fire it up and see what happens. All right, I turned the heat pump on. We're running off grid, 2 units powering it. Let's see if it starts up. Heard the relay click. Put the mic right here. How about that? That is the smoothest startup I've ever had with one of these transformerless inverters. That is awesome. 4-ton heat pump test? Check. And you can see once it starts up, I mean, we're only pulling 2,300 watts or so. It's not the running that's hard. It can run it all day, no problem. It's really not that much load. It's the starting that's an issue. And if you want to have any chance at all to get it to start, you're going to need one of those soft starters. The one I use is Active Start. I don't need any kickback from them or anything, but they actually worked with me to mature the hardware to work with these transformerless inverters better. So I'm pretty confident that one will meet your needs. I haven't had experience with the other ones. So anyway, I'll link to it in the description below if you want to get one of those for your system. Even if you don't try and run your system off grid, the dramatic improvement in the smoothness of startup of the compressor is amazing, and it will probably make a big difference in the life of the system. So it's probably worth having one, even if you don't need it for backup. All right, now for something fun. Thermomate sent me their 11 kilowatt, 240 volt on-demand hot water heater so I could use it to test out these units. And I've always been curious if these really inexpensive on-demand hot water heaters can actually deliver. So we'll kill 2 birds with 1 stone. Can we actually make a shower out of this thing, and can these units power it? This tiny little 11 kilowatt heater claims to be able to deliver a little over 2 gallons per minute with a 35-degree temperature rise. And it's only $200. Plus, if you use the discount code that they gave me for my viewers, you can get another 10% off of that. So let's take a quick look inside. This thing is super simple. It's really simple to wire. It just requires 2 30-amp breakers, so 2 sets of 10-gauge wire for each channel and 1 ground. There's a circuit breaker and 2 resistors, one at the top and one at the bottom. Each one is on one of the breakers. So you can actually run the unit off of just 1 breaker. You'll just get half the power. There's a flow sensor and a thermocouple, so it knows the flow rate and the output temperature. Using that information, it throttles the amount of power going to each one of the resistors to get the temperature to whatever you set it at. So pretty simple. So I made a really simple test setup here. I have a shower connected directly to the output, and I just ran a hose for now to the input. The hose will deliver our cold water. I have a thermocouple taped to this brass fitting, and that'll give us a pretty good idea of the input temperature. And then I have another thermocouple that I'll put in the bucket to measure the temperature of the water in the bucket. And I'm just using this data logger to collect the information from the thermocouples. I've marked off gallons in the bucket so I can measure the flow rate of the water coming in. So we'll be able to determine the temperature rise, the flow rate it can deliver, and then we'll also track how much power we're pulling from these units. Now, 11 kilowatts is 1 kilowatt below the max for these 2 units. The 2 together should be able to deliver 12 kilowatts and a little headroom for surges. So I think it'll power it without a problem. But is it actually going to heat the water? Let's see. All right, you can see the light is off for grid input, so we're running only off a battery. Let's set our target temperature to 120 degrees. I'm going to start with this bucket till it starts warming up, and then we'll switch to the one that I'm measuring with. All right, let's see what happens. Ooh, it's already warm. That's pretty nice. Actually, I'd take a shower in that. What is that? What do we have coming out? 106 degrees. Let's switch buckets. Ooh, 113 degrees, which matches the output. It says it's putting out 114 degrees. I'm measuring right at 113, and we're going to lose a little heat in the bucket. We're pulling 5,300 watts out of each inverter, pushing these things pretty hard, and yet I don't even hear the fans coming on yet. Now, we were getting 113, and it's come down a little, and that's because the water coming in is getting a little colder. I bet you it's actually colder than that. It says it can do a 35 degree temperature rise. It's actually a 42 degree temperature change. Woo! That is hot. I'm pretty impressed. Like, you could actually just hook up a hose and take a shower. This is pretty cool. Like, there's times in the day we have a lot of extra solar, and you could just take 11 kilowatts at a time and just take a shower. Running out of space in my bucket. Been running for several minutes now, and I can hear the fans starting to pick up on those guys. Okay, it's 106 degrees. So the water coming in is getting a little colder. It's down to 66 degrees. So the water coming out isn't quite as warm either, 106. But that, I mean, that's still plenty hot to take a shower. All right, after about 10 gallons of water, I think we stabilized 66 degrees in, 106 degrees out. With the shower off, I can hear the fans running. I mean, they're not super loud, but they're definitely running. We gave it a run for its money. Well, they're petering back off now. Okay, this thing's rated for a 35 degree temperature rise at just over 2 gallons per minute. I was running just under 2 gallons per minute, and I was getting over a 40 degree temperature rise. So that's pretty impressive. I'd say it pretty much meets what it says it can do. And it's actually sufficient. I mean, especially if you were running a hose into this and you coiled the hose outside in the sun before you ran into it, you could get some really hot water from that. Well, that's a pretty cool test. The units were able to power it no problem. The on-demand hot water heater was able to provide hot water, and that would be a really good way to have a dump load in the middle of the day when you have a lot of extra solar and you need to get rid of it because the batteries are full. You could run an on-demand hot water heater and take a shower. Get rid of some of that extra energy. All right, the heat pump just kicked on. We're pulling 1,200 watts per unit. Let's kick on this on-demand hot water heater and see if I can shove it over the edge. $5,600 watts, 6,300 watts. Woo-hoo-hoo. Wow, look at it go. 6,400 watts per unit. All right, I don't want to shut the thing down because my AC is running, but that's pretty good. I mean, I ran it at least for several seconds at 6,400 watts per unit, so that's about 13,000 watts between the two, and it held it up. It didn't even make any noise. In fact, the fans are barely running, so based on the testing we did on a single unit, I would say that's pretty close to the maximum that it could do. And even with the two combined, it doesn't look like there's any degradation in that max. So all in all, I think that's a pretty good result. Well, that's pretty fun. These units can really deliver some amazing performance. So let's look at pricing real quick. The battery capacity in these units is 3.8 kilowatt hours, which exceeds the 3 kilowatt hour threshold for the US 30% tax incentive. On top of that, in the description below, I have links with exclusive discounts that you can use for purchases through Signature Solar or for purchases directly from Anker. A single F3800 is on sale right now for $26.99, minus additional discounts and tax incentives. If you're counting on a tax incentive, make sure that you qualify with your tax advisor before you go and make any purchases. Anker has a whole variety of packages to choose from that are tailored to whatever your specific needs are. Some packages come with home power panels or expansion batteries. You can also get any of the packages with folding or fixed solar panels. You can purchase similar packages through Signature Solar using the discount code provided in the description below. You might consider purchasing through Signature Solar if you need other components or you're looking for a lot more options in the solar panel space. They have some of the best deals on solar panels, including bifacial solar panels, and if you've watched my other videos, you know that bifacial panels provide a lot more power in most scenarios. Are you interested in doing solar yourself? If so, check out one of these videos, or go to my website, projectswithdave.com. I have some very interesting test results and lots of interesting projects coming in future videos. Thanks for watching, and I'll see you next time.